Connor Archibald here, lead software engineer at Dynamics. I'm talking to you in this video about the entity type specific parameters. So for each entity type, what parameters you need and what they mean, as well as the parameters that mean something for all entities, depending on their propagation type or some other thing like how they are rendered in the Unreal Engine portion of our application. So Source Explorer is a good starting point for a simulation that has lots going on. So going down to the entities, we have the spectator one entity, which is of type pawn. This entity is going to need to have a few parameters on the pawn section of it that will tell the Unreal Engine application as well as well as the other parts of our application how to spawn it and how to manage it. So BP path is the path to the Unreal Engine content asset that is used to spawn this. So this is a fixed value that's for any BP class that we use. We'll have entity templates available for entity configs available for most of these already, but in some cases you might need to copy from another simulation to find the BP path that you're looking for. For any pawn, it needs a role name, its possessed, and username. Each of these is a parameter that's used in the role picking process. So if your simulation has multiple pawns in it, which are the pawns are entities that can be controlled by a player, by a user, and that means that we have to have a label for what role that they are in the simulation. Is possessed is used during the simulation, and is possessed will be true if somebody is possessing that pawn. The username will be set to the username of the user who's possessing that pawn. Graphics frame is used for a set of backend code that does special handling of the coordinates that you see from on your end whenever you're possessing this pawn. So the graphics frame that you set here will be used as the starting point for the what the Unreal Engine portion of the application will use as the origin. So this is only really important whenever you have a case where you don't have a pawn that does not do graphics frame transitions or is set up to not do that, and you want to hard set it to one graphics frame. So if your graphics frame is a body that is far away and moving very differently to the area of the simulation that you're spectating on, then you might want to set the graphics frame to a different object that is either the object that you are looking at or an object that's close to it or moving with it. For example, if the graphics frame transitions were off, we would want to use Mars for a simulation that's meant to be around Mars. Now that I mentioned the graphics frame transition stuff, if I go down to the transition graphics frame and constrain z-axis of planet, these two parameters, which are at the top level, they're not inside the pawn, these two are used to tell the pawn whether it should do transition graphics frame, which, as I mentioned, changes the graphics frame to the closest object that is considered relevant for graphics frames, which is the planets, typically. And constrain z-axis of the planet, it changes the rotation code of whatever pawn you're using to constrain your z-axis, what direction is up for you, to out from the planet. So if you have this be false, then you'd still be using source system wide up instead of the local up for whenever you get close to a planet. We do have code that's able to roll you around depending on which pawn you're using, but it's usually really convenient to have that snap to Z is the correct up whenever you're close to a planet. No clip is whether the pawn should collide with objects. So that is a parameter that we set false if we want to make it so we won't get stuck on terrain or on other obstacles or inside of a vehicle or something. You can go through walls with no clip being true. There's a few pawns that use attached to entity, but that's typically not necessary these days because of the capability of just saying transition graphics frame false and sending the graphics frame to that entity. It can be used sometimes if you want to have this pawn be attached to that, but sometimes it's not. It gets into a state where it doesn't work quite well. Now to the state parameters. So these are parameters which are talking about the location, rotation, velocity, angular velocity, etc. So depending on propagation type, if it's no propagation, not propagation type, that means that there is no actual physical significance of where the entity is in the simulation. So the entity is just used for its data and nothing else. So this is usually only valid for a entity that either does its own movement inside of our Unreal Engine application or is a data type entity, which is the type where there is no like real parameter necessary besides the required section. If you have a propagation type that's not no propagation, then you need quite a few things. You need to these will be added if they aren't there already, but it's nice to have them. The location, rotation, velocity, etc. All these are used for moving your moving the entity around, and depending on the propagation type, they'll be either be set by a user that's controlling them, or they'll just be a kind of read-only thing that comes in from the compute server or some other system that sets it. So propagation types are explained a little more in depth in the wiki, but when whenever it's not no propagation, then you need to have these parameters be at least settable. The frame that's used for these parameters is the body fixed frame of the value of resident frame. So, for example, this location starts off this pawn as negative 10 E6 in the X direction, which is negative 10 million meters. That's so that's basically behind Earth. It's in the body fixed frame of Earth. So if Earth rotates a little bit, that means it's still going to be behind it and the same relative orientation and position compared to the Earth like body fixed frame. So if we want to change this to something else, that would mean that this appears somewhere else. There is a bug in 0.20.6, I think, that and it has been there for a while, where it sometimes doesn't work to give it a different resident frame than the Earth in some sims, depending on where it starts out. That could be fixed with some other code, where or it can be fixed by going into the simulation and saving it from the syncfig editor, and then just loading the results from there. The rest of the dynamics parameters, interpolation type, that's actually deprecated. We no longer use that for anything. His rebase center is used for the rebasing process, which is another coordinate thing that we do. You want to have this be true for the pawn that is being used as the user, the pawn that's being possessed will have this rebase center be set to true. This makes it so that the coordinate system that we use doesn't get too far from the origin. There's a few other things that could go wrong if this is not set to true on only one entity. Jury collider is unused. We do use mass though. Mass is mass in kilograms. That is used in some situations. But if you actually have dynamics going on with something, you might need to have the full set of parameters that are used for that. So I think I have those on the ISS in here, for example. This is a different sim, ISS live.json. We have this is what's used for the live ISS telemetry sim. So in here we have the ISS, and in its dynamics parameters we have propagation types, compute acceleration. This is an example of one of the things where it's meant to be used when you have the location and other things coming from a compute server system or some other place in the platform, but it's not being controlled directly by someone with a keyboard and mouse in Unreal Engine. So propagation type with that means that we have our ISS orbit propagator system, which is just the name tag for our rigid body propagator that we used inside this sim. And that's able to set its parameters here. The rigid body propagator is it propagates rigid bodies using using Newtonian physics. So from the force and torque variables here, as well as the inertia and other things in this entity, we're able to propagate it forward in time, moving it due to its velocity and location, etc. So this inertia matrix is just a 3 inertia matrix with the inertia coefficients. So this would need to match up with the mass to make this a valid object. The force and torque here are set externally using the set force and set torque functions. Those are the values of them are also in the resonant frame, same, but the inertia is in the body frame of the object, so it doesn't change as the object moves through space. Sometimes you'll get notations in code or in modeling software where it's inertia in the kind of world frame, like the exterior frame or body center frame or something. That will mean that the inertia will then be changing over time as the body rotates, but body fixed frame inertia only changes if the mass properties of the body itself change, which is something that's not what a rigid body does. So disable propagation is used for a few systems when we want to kind of pause the propagation and just let it have something happen to it. So for example, maybe that's because we have it attached to something else and we don't want it to be simulating physics yet. We can have it disable propagation until we are ready to start simulating physics. And then it's able to take we have to set that to false, and then the rigid body propagator can take over from there. There's a few other parameters that we have in here. Scale in the graphics section and render far, they're not used yet, but we will probably have uses for them in the future. There's the entity object type, which is not used very often, does allow for scale to be used as a parameter, which just uniformly scales the size of the object up or down. And then we also have the scale 3D parameter in the object loaded type, which I don't have an example of up right now, and that is able to scale in 3 dimensions, but it's only for the object loaded one for that one. In some legacy systems, you might see multiple of these things up there. That's just because it's just out of convenience for typing. We didn't want to keep adding this right there, so it was just easy to change that to object, and now it's acting as an object and using these parameters. There's no actual meaning to having multiple of these, other than it's just a typing convenience thing if you want to change between them. So you don't need this field here if you want to use the stem. Generic collider is also not used. It was going to be used, but and it might still be used in the future, but we currently don't use it. We just have the properties of the blueprint that you're using or the other object that you're using determine whether there's some sort of collision. Let's see about some other things. So gadgets in here. Each pawn has a list of gadgets which are used to set the UI that you see whenever you load into a sim. So taking the list of gadgets here, we have a time gadget, which is pretty standard using the time management widget class. It has these particular properties where if it's static, you need to have these anchor and alignment and position parameters to set the static position of the widget. If it's not static, then you don't need to have those because it just spawns in the middle of the screen as another movable widget, which has a kind of a dragging bar that you can click and drag onto to move it around. Starts visible determines whether the widget will start visible inside the UI. So this is set to false for Planet Graphics, but you can get it to be visible by pushing the button for it. And the texture 2D tagging texture is just which icon you use to show next to the name in the toolbar. Okay, attached to entity. This is an example of it actually being used. This is on the if we set this to OP2D orbit, it would do the same thing. Spectator and orbit are pretty similar. The spectator is like where you can fly anywhere around the sim. UOP2D orbit requires that this attached entity parameter be there, and it does a relative motion where you're kind of looking at your object from a from like behind, it's kind of basically the same view as Kerbal Space Program. Graphics frame. I mentioned how that works earlier. This is one that's set to the ISS just to simplify things so that it doesn't need to do a complex rebasing. So this is a good example of the from template class, from template type. We have a from template entity type, and the source path that it used is this source path. So if I go to that folder, shared data, SE assets, solar system, when I find that, assets, source system, Earth, occupants, clouds only, I'm able to open up the entity config that is used for this. So entity configs are basically the sim config reduced down to just a single entity. And this is what is used to we reference an entity config like this with the from templates type, and then it loads up this entity config and loads up these parameters, then adds any parameter overrides, which are just if you put parameters into the parameter overrides, that means that the parameters that are there are the new added or changed values of the parameters that were inside here. So I could go into this and say, I want the body to be moon instead of Earth and do it like this. So parameter overrides on this. Now the body is going to be moon. And that would mean that whenever this exists in the simulation, the body parameter would actually read moon instead. I'll revert that. So this is the details on the entity config. So the type matters. Everything is basically exactly the same, except the systems aren't parsed. This is just I wrote this in there because that's what it would usually have as a little bit of a hint to the sim developer. But we have the systems inside the entity config don't actually matter. They will be discarded, and then the systems that you apply in here are what actually matter inside a sim config. And if you do any entity refs in an entity config, it will likely be invalid because there's no other entities around to have for that. So we use instead, you'll probably want to use param overrides to set an entity ref on this. Whatever you have a entity that's using spicy, which is our planet ephemeride. This is a little bit of size. It's a little more deep than you need to know. There's the body frame, and correction variables. Those are necessary parameters for spicy to use, because this is the body that the object represents. The body frame represents the rotation kind of basis that the body that this object should be rotating as. And then the correction is just a for light time correction. We don't use it typically. We will in the future though. So back to up to here. Let's see if we missed anything. We want to go through the you'll find it in here. These are all just from template type for the most part. If I go to, for example, I'll find our one of our sims that is used to do a object loaded. Go into proxop sims, target chaser to JSON. So in this sim, we are using the oh, it's not currently selected, but it would be selected if it is in there. See if we can find that in this. Nope. Okay. Well, if we change this to BP path and change that out, now it's using the runtime mesh load blueprint in here. There's a better example of this in the importing video, but I'll go over the basics in here. So you import a CAD file by having the model import path parameter be set to a certain path like SpaceX Starship.tlcf. This is in the shared data folder. There's a few other folders around. You're also able to once we fix it for this in particular, you'll be able to use it from user files. But for now, it's still just you are specifying your path relative to the top level folder of the workspace you're in. So this path goes down to some sort of 3D model, which details are explained in the model import video. And then scale 3D is applied. So this is the XYZ scale that's applied to this after it's loaded in. And this entity loaded BP that has code in it that loads in the model, loads in material assignments and texture assignments if those are also supplied, and makes it render in the simulation. So you're able to add 3D models without having access to this core source code by using this functionality. This will later become its own entity type, the object loaded class. It's currently deprecated because we just used a slightly easier version to make this blueprint, but it will be a little more standardized in the future. So talking about a few other simconfig notation things, because we didn't get talked about in the last video. We have an array here. So the first value is array. The second value is the type of the parameters used in that array. So it's the same syntax as used for the other like square bracket parameter value thing. And then the rest of those are the values of the array, values in the array. So this is an array of strings and it's location, velocity, rotation, etc. Yeah. So this code in here is doing a complex simulation with a lot of different parts. We have if I go down to the systems, which you might need the Control F for that, systems. No, not those systems. This ones. We have a rich body propagator that is doing the Earth orbit propagation for certain bodies. Its options are the propagator's two-body gravity propagator, which is a simplified one, and the propagation sharing center is at Earth and a few other things. We have command and gist happening. We have telemetry out. We have orbital elements calculator, data monitor, a thruster firing thing, and then task flows, which is something a little bit new. So task flows have a set of systems that have dependencies between them. So if a system is task flow task type, then it can go into a task flow and have a loop happen over the entire task flow instead of for each of these systems. So task systems don't have their own frequency; they just get added to a loop. And the simplest way to do this is to just say, okay, I have a dependency that spicy runs before this, and this also this runs for that, and this runs for that, and then it will run each loop of the task flow with these dependencies, where it will make sure that spicy is done before it starts this, as well as that's being done, and then this run for that. So it ends up being that spicy and chase rushes run, then Earth Orbit Propagator, then dilemma out. That's it. Good amount for this video.